Okay, let's get started. Thank you for joining us for the third webinar on agrovoltaics, farming meets solar power in Africa. This is a third webinar in series, and I want to recap the objective of this webinar series, particularly for those who never attended this webinar and attending this one for the first time. We are not just providing you information, just not learning opportunity. So this webinar is aiming at the concrete outcomes. First, to implement agrovoltaic pilot projects in Africa. And second, to form African Agrivoltaics Association as a platform or network to promote the agrovoltaics in Africa. So today's entire program is 60 minutes. First, we're gonna hear a presentation 20 minutes from Dr. Richard Lando Bogis. That is followed by 30 minutes discussion and question and answer sessions. For audience, please write your question in the question and answer box that you can find at the bottom right of the Zoom screen. So let's get started for the presentation of the Dr. Richard Lando Bogis. He is currently is research associate of the University of Sheffield. He obtained his PhD degree in 2016 from the University of New York. He worked for the various research organizations and private company, the University of Glasgow, Lancaster University, and the private company, Hotel UK Limited. His background spans in multi-discipline, from biology, environmental science to renewable energy. And he said he has a vision to create holistic solutions to tackle complex global challenges. And he is now leading a multidisciplinary project from research, innovation through to development. Currently, he is managing an agrovoltaic project in East Africa, which he presents today. So let's hear more in detail from Richard. Please welcome Dr. Lando Bogis. You can take floor, Richard.
Brilliant. Thank you very much, Makoto, and hopefully you can all see my screen okay. Thanks very much for the introduction, and good day, everybody, joining us from all over the world. So, as Makoto said, I'm Dr. Richard Randall Bogis, a research associate at the University of Sheffield, and I'm working on the Harvesting the Sun Twice project, which is led by Professor Sue Hartley, the Vice President for Research at the University of Sheffield in the UK. And this project focuses on enhancing livelihoods in East African agricultural communities through innovations in solar energy, namely agrivoltaics. In this talk, I'm going to give a brief introduction to the agrivoltaics concept, and I'll keep this brief because by now most of us will be familiar with agrivoltaics, but just in case there are some people joining us for the first time today. And then I'll talk about some of the factors that affect the results, because from other studies around the world, the results can be wildly different depending on the system. I'll then talk specifically about why we're looking at East Africa and the potential benefits of agrivoltaics in the region there, before I talk about the project that we're conducting in the region. And then I will end with a roadmap of how we can support the development and uptake of agrivoltaics across Africa. So a brief introduction to agrivoltaics. On the left here, you can see a conventional ground-mounted solar park. This provides much needed low carbon electricity to national grids, and the land here is well managed for biodiversity conservation. But the primary land use here is low carbon electricity. But on the right, you can see an agrivoltaic system. And here, the panels are raised up and spaced apart to allow for agricultural activities underneath. And the design of the system is key. By having the panels spaced apart, lets some sunlight through to the underlying crops while we still get the electricity. So you have that dual use of land. And depending on the location and depending on the setup of the system and the crops used, agrivoltaics can create actually a favorable growing environment. So this can increase crop yields, or it could allow for certain crops to be grown in areas where they could have been grown before. And one of the main drivers behind that is the fact that the partial shade can reduce evapotranspiration. So in hot climates, areas where water loss and evapotranspiration is a challenge, the partial shade, just like shade netting, can reduce the water loss from the systems and increase crop yields potentially. But a little bit like how the stock market can go down as well as up, it's the same with agrivoltaic systems. And of course, there are many factors that affect the performance, and in some cases, yield can be lost as well as increased, or yields can be decreased. So there are several factors that affect this performance. Many of those environmental factors, of course, will essentially be tied to the location of the system. So the amount of solar radiation will affect the crop yields that we can see from the agrivoltaic systems, and other factors such as air temperature and the amount and predictability of the rainfall in an area. But one of the biggest factors will be crop type. Some crops will grow well and in fact will grow better underneath an agrivoltaic system in a certain location, whereas other crops might not grow so well. And again, this will vary depending on the location. Some crops might grow well in one location, but in another location not grow very well at all. So these are some of the environmental considerations that we have to think about when designing an agrivoltaic system. And there are ways that we can help develop the systems to optimize them for certain crop types and situations. For example, by changing the panel density, it may be a case that the land availability isn't so much of an issue, and so there's more space to be able to have larger gaps. Hello? Sorry, can you still hear me? I think it's just cut out.
No, here is Ibrahim. I can hear you. I don't know if you hear me.
Okay, great. Sorry, my Zoom just decided to restart. I'll just share my screen again. Okay. So as well as the environmental factors which affect the performance of agrivoltaics, there's also some human considerations as well. So what would be the greatest benefit from these systems? They could be attached to a national grid and, as I mentioned earlier, provide much needed low carbon electricity. But the greatest benefits really will come from those off-grid situations where agrivoltaics can provide electricity for communities that are currently without energy access or without electricity access. And I should say electricity, not energy, because the communities may have energy through diesel generators and biomass burning. But of course, having low emission infrastructure such as solar panels can have implications for the health and air quality, and particularly in the household, which actually disproportionately affects women and children, because more women and children spend time in the household and around the cook stove. So if agrivoltaics can power electric cook stoves rather than being biomass that's burnt, then that can have air quality implications within the home. As I mentioned, the agrivoltaic systems can create a favorable growing environment and can increase the yields of certain crops. it can also allow for some crops to be grown in an area where they couldn't be grown before. And one of the considerations is there the markets and the supply chains to deal with those new crops? As an example, and I'll talk a bit more about this later, but one of the systems that we're setting up in Kenya, and we're going to be growing strawberries with a partner farm where they didn't grow strawberries before. So strawberries could be a high value, nutritious crop. And we're hoping that the agrivoltaic system will facilitate the growth of strawberries there where they couldn't be grown before. But of course, there needs to be the market. And then finally, another thing to think about for supporting agrivoltaics is there policy support. And also, the interesting thing with agrivoltaics is that it pretty much evenly spans energy and agriculture. So we need agricultural policy to support it, energy policies to support it, and we need harmony between those policies as well. And I hope I'm correct about this. I believe that in Japan, the land use policy is that agricultural land cannot be fully converted to energy. So we can't remove, or in Japan, they can't remove agricultural land for energy production. And agrivoltaics, therefore, gets around that issue by maintaining and retaining the agricultural land while also providing solar electricity. So there's a need to understand the policy around this as well, and also getting different sectors to talk, getting the energy sector to talk with the agricultural sector. So there's a lot of studies that have now started to crop up around the world to explore and determine the benefits and the performance of agrivoltaic systems. But you'll see here that there's a big question mark over sub-Saharan Africa, or over Africa. I do know of a few projects like ours that are starting up now to explore agrivoltaics on the continent. But the main thing here is obviously I've chosen this background for a reason. You can see that the solar radiation is incredibly high. The potential for solar electricity production is huge. And also, as we know, there are significant environmental challenges for crop production, often associated with water availability. And so if the partial shade from the solar panels can reduce water loss, then that could have implications for food security as well. So there's a huge need to research agrivoltaics in Africa and determine those benefits, because arguably the benefits that we predict in the region will be the greatest of all of these, or many of these pilot studies around the world. So why specifically are we looking at agrivoltaics in East Africa? Well, firstly, almost 2/3 of the population of the region don't have access to electricity. So that's hundreds of millions of people who don't receive all of the benefits that electricity can offer. As I mentioned, powering fridges to store medicine, to store food, powering post-harvest processing to reduce yield losses of crops or increase the value of products for farmers. As an example of this, when we were at a research centre in Nairobi, they had a hot water bath for treating mangoes, and the hot water removed pests from the mangoes, so that would reduce yield losses. And that hot water bath could be powered from an agrivoltaic system. We could take some of those processes closer to the production from rural agricultural communities. And that's one of the other things, is that a lot of agricultural communities in East Africa are rural and are off-grid. In fact, the International Energy Agency has reported that to achieve universal electricity access around the world, 71% of the investment needs to be spent on off-grid and mini-grid systems. So not expanding and improving existing national grids, but developing off-grid and mini-grid. The report also states that the majority of that investment needs to be spent in sub-Saharan Africa. So there's a real energy security challenge in the region. There's also a food security challenge. 75% of the agricultural systems rely on rainfall. And as we all know, climate change is happening. We all know that global air temperatures are predicted to increase on average. But specifically for East Africa, this means that rainfall events are going to become more unpredictable. So it's not predicted that the rainfall will become significantly more or significantly less throughout the year, but it will become more unpredictable. And this is going to present a real challenge to those farmers that rely on predictable rainfall in the region. And in fact, by the IPCC medium emissions scenario, it's forecast that major crop yields are going to decrease by 2050 by 8 to 45%. So there's a real food security challenge both now and in the future with expected climate change. And on top of all of these challenges, there's also a growing population. And the population of the region has grown by 72% in the past 20 years. So that's more people who will need access to safe and nutritious food, a greater demand for electricity, and also more people who are going to be affected by climate change. And this is where some of the benefits of agrivoltaics comes in. Now, I know that we've been through many of these benefits before, so I'm not going to go into these in detail on this slide, but I've just highlighted a few key ones that I want to talk about. So, for example, the electrification for off-grid communities. So this is really going to have a great benefit for those agricultural communities, while also maintaining that traditional land use of agriculture as well on the same plot of land. I've already mentioned about the, potentially creating a favourable growing environment. And what this can mean is that marginalised agricultural land where some crops are grown but the yields are particularly low and they're limited by environmental conditions, could be improved by the favourable growing environment underneath the partial shade of the solar panels. And also, again, certain post-harvest processes could be powered, which could reduce yield losses, refrigeration to store crops for longer. And interestingly, it's not just a spatial effect here where marginalized land could be improved, but also growing seasons, depending on what the conditions are and the features of a growing season, they can be extended as well. So, and this is something that Greg Barron-Gafford at the University of Arizona has reported, that the potential to extend growing seasons by pushing back some of the environmental limits as they come into play. A really interesting point about agrivoltaic systems is the potential for rainwater harvesting. Because this is a relatively simple concept. It would just be a case of having guttering on the lower edge of the solar panels. So when it rains, you've got a very flat surface that can collect that rainwater and store it in a raised water tank. And then that can be used to slowly irrigate the underlying crops over a longer period of time as well. So rather than it being a heavy rainfall event onto the crops and then the water either running off the surface or evaporating, you can store that water for times of particular need for irrigation. That also has implications for soil conservation as well. A lot of conventional solar parks, particularly ones that I've seen in sub-Saharan Africa, the land is just cleared. So the vegetation is cleared and it's bare soil with low solar panels mounted on top of it. And that soil is exposed to surface runoff and it's exposed to wind, which can erode the soil. Having the vegetation can maintain can help improve the soil structure, so there's less soil erosion there. And also by having those the rainwater harvesting, you collect the rainwater rather than it running off the lower edge of panels, which creates a bit of a channel of soil erosion underneath. And so these are several of the more, I suppose, physical benefits and broad benefits, but in particular for the local communities, this can offer diverse income streams from the sale of crops and potentially introducing higher value crops and reducing yield losses and improving products, as I've mentioned, and business opportunities. But another particularly interesting point is that the partial shade for the panels not only shades the crops, it can also shade the workers. So if it's a hand-picked crop, then the workers will be in partial shade, which will have health and well-being implications. I've already mentioned the household particulates and that the agrivoltaic system could replace biomass burning. This also has implications for deforestation because there's less need to collect firewood. And another point is the potential for gender inclusion. In East Africa, the agriculture sector is split roughly 50-50 between men and women, whereas the energy sector is predominantly run by men. And so by incorporating agriculture into the energy sector, this presents an opportunity for more women in the community to become involved in energy decision-making. So those are some of the potential benefits, but there are also several questions that we need to explore, we need to answer to understand how best to develop these systems, not just to optimize results, but also make sure that we don't end up with the systems coming at a cost, both a financial cost and a food security cost as well. So how do we design the agrivoltaic systems? How high do they need to be for the agricultural activities underneath? How far apart do the panels need to be spaced? Different end users, different stakeholders of the system will have different needs. So some people, the priority may be having maximum electricity production, whereas other farmers might have not need so much of the electricity production, and it might be a case of designing the system for optimal crop growth underneath. Of course, there's which crops do we grow, which crops are suited to the area and will grow well under partial shade. How do we work with the local community? Something that I know Makoto wants to talk about is the optimal business models, as well as doing all of our research. How do we support the sustainable and effective rollout of agrivoltaic systems so they can be fully functioning and self-sustaining within the market? So there's all sorts of questions here, and I'll have this slide at the very end of the talk as a bit of a discussion point as well. So this is where our Harvesting the Sun Twice project comes in to explore many of these questions. This is a £1.4 million project, which is funded by the Economic and Social Research Council, and we have a broad range of partners based in the UK, the University of Arizona in the US, and also several partners in East Africa with a range of different specialities to deal with this multidisciplinary project. I won't go over this in detail, but this is just an overview of what the project structure looks like. And we have three main work packages. The first work package primarily looks at understanding this is a bit like a context review. So what's the policy that would support agrivoltaics, or indeed perhaps hamper agrivoltaics? What do the local communities think of these systems, and what's their input into designing them, because it's best if they're co-designed? And also, what are the actual the physical performance outputs? So we have two pilot studies, which I'll talk about in a moment. Work package 2 then goes beyond our sites, and it starts looking across East Africa to identify the best places where agrivoltaics can be developed, and I'll talk a little bit more about that later, and also creating a decision support tool to help guide the development of agrivoltaics. And so work package 2 would be creating that decision support tool, and then work package 3 is essentially the rollout and supporting the rollout and dissemination of our project. So creating policy briefs, creating development handbooks, and disseminating the decision support tool to work with and engage with local stakeholders to support agrivoltaic uptake across the region. So now I'll talk specifically about our two pilot studies. We're potentially exploring a third in Uganda, but for now I'll just talk about the two which are currently being set up. And construction has begun in Kenya, and in Tanzania it will be beginning in the next couple of weeks, and we aim to have both finished by June. What's really interesting about these two pilot studies is both host stakeholders are agribusinesses which specialize in farmer training, capacity building, education, and dissemination. So they're both businesses which engage with the local farming community, and they're ideally positioned and set up to share our results and work with the local communities. The two systems, the one in Kenya is a grid tie system, so connected to the national grid, and it's a 65 kilowatt peak system. And the one in Tanzania is an off-grid system, so that's slightly lower capacity, but it has battery storage. And both of them are located in a semi-arid region. So we'll hope we're expecting to see significant, interesting results from the crop production in these semi-arid regions where water scarcity can be an issue for crop growth. So a little bit more about the design of our system. One of the particular interesting points with agrivoltaics is it's not just an energy engineering project. You have to think about the crops underneath as well. So one of the first things to note here is that this doesn't look like a conventional agrivoltaic solar park. You can see the north is facing the top there. And the reason that we've gone for this design is because with a conventional solar park, the arrays, so the rows of solar panels, run on an east to west axis. That's the way that they're conventionally designed. And as the sun would move across the sky during the day, this would mean that some crops primarily receive direct sunlight, and some crops primarily receive the shade from the solar panels. So what we've gone with is a north-south axis, so that as the sun moves across the sky during the day, all of the crops will receive a mixture of direct sunlight and partial shade. And we still have the panels angled towards the sun. They're angled towards the north because we're just in the southern hemisphere, and they are also angled to allow for rainwater and cleaning water to run off the surface of the panels to help clean dust off them as well. And I had a meeting with Fraunhofer Chile a couple of weeks ago, and they were talking about the fact that having flat solar panels is a real challenge for dust buildup and soiling on the panels. So you want some angle just to allow for that water to run off. And you can see the guttering in the design as well. And we also have 3D models of both systems. This is the setup that we have in Tanzania, and the one in Kenya is slightly larger than this. And you can see the storage tank for the rainwater, and then the rather interesting design that we have. So this is a 50% density. So we're going to have high energy density output from this, but also still sunlight getting through for the underlying crops. So I'm now going to talk about a couple of the results we've had so far. The reason why construction has been delayed slightly, but is now underway, like pretty much all projects around the world, we've been affected by the pandemic, but we have been able to conduct some of the desk-based research. So this was a spatial suitability analysis that was led by Christine Lamana in eCraft Nairobi. And this was just an initial experiment to explore where would agrivoltaics be best situated in East Africa. So we looked at some environmental parameters and some human population factors to then determine two main outputs. So that's plots E and F, which I'll talk about in a moment. The amount of solar radiation across the whole region was sufficient for electricity production. So the main thing we looked at, the main parameter here, was the number of people, the population density without access to electricity. So this is where some of the greatest benefits of an agrivoltaic system would be achieved. And we then looked at factors affecting crop production, so the amount of rainfall and also the land use, or the probability of land use being agriculture. And the rainfall was interesting because we used a low rainfall amount of 800 millimeters a year as a cutoff for to classify land as marginal. So this is where some crops could be grown, but the rainfall is going to be a limiting factor in crop yields. So then the first output from overlaying some of these parameters is looking at where there's land use conflicts. So areas of high agricultural productivity, but also a high demand for solar electricity. So here there could be conflicts between developing a solar park and agricultural land use. And by having an agrivoltaic system, you avoid that land use conflict. And also you avoid the need to clear new land or deforest land to create an agrivoltaic system if you didn't want to take from the agricultural land. So you avoid that conflict. And of course, you can still receive the other benefits of increased crop yields as well, depending on the system design, depending on the conditions that I mentioned previously. But one of the most interesting outputs is this enhancing marginal cropland. And this is the areas where there is a need for electrification, but also agricultural productivity is relatively low. And so by putting an agrivoltaic system here, could this actually improve that marginal land, increase crop yields, and potentially facilitate the growth of new high value, nutritious crops in an area where they couldn't be grown before. So that's the output from the spatial analysis led by Christine Lamana. And then we also have this is very new work. We've only discussed this last week. This is undergoing research led by Steve Sinderby and Casilde Mahuza from Stockholm Environment Institute, with Steve based in York and Casilde in SEI Africa. And the work they're conducting is interviewing the stakeholders around the pilot sites throughout the development of the system. So before it's developed, during its development, and then later on after it's completed, to essentially understand what we're calling their user journey of agrivoltaics and what are their thoughts and perspectives of these systems as they learn more about it. And so these are just some of the first findings. So this is undergoing work, but these are just some of the key points that we've taken from those interviews. So one of the findings was the need for an agrivoltaic champion. This would be a champion in the region who can speak with other farmers about an agrivoltaic system, talk about why it's designed the way it is, what the potential benefits are, what challenges there are. So essentially helping to support the uptake of agrivoltaics, and also just to engage with the wider community as well. So the wider community understands what's going on when there's a solar park that's on stilts, essentially. Some of the opportunities that were recognized by those stakeholders was diversifying into new agricultural processes, so powering irrigation to improve crop productivity, and also, as I mentioned, post-harvest processing. They also recognized the benefits of lighting for evening activities, and of course the commercial and economic opportunities for solar developers and also for agribusinesses as well. But that last one comes with a challenge. I'm just talking about the bottom challenge point here, is that also comes with a learning curve. So it was acknowledged that there's going to be a steep learning curve for developers and engineers designing these systems. And that partly comes from the fact that we're talking with solar developers and solar engineers in a sector they may not have worked in before. They may not have an understanding of agricultural systems. So it's quite a challenge to bring those together. And that's largely why these research projects need to be set up to help those conversations and help that sharing of knowledge. They also, and this is very important, were concerned about security risks. These are high value systems. They're also going to be raised up and on show to the local community. And so they're worried that the solar panels could be a target of theft. And so this could come with an increased cost of security for the systems. Not just security against people either. In our site in Tanzania, we're having to put up elephant fencing to protect our research plots there. And finally, there was also the mention that an agrivoltaic system can prevent mechanized agricultural activities. That's not always the case. Fraunhofer ISE in Germany have demonstrated an agrivoltaic system which is designed to allow tractors underneath it, but of course that does come with an inherent risk. And also the system will be more expensive, and it'll be higher up, which will be more challenging for maintenance and for cleaning, etc. Another thing to think about for developing agrivoltaic systems, particularly in East Africa, is affordability. A lot of the conversations that I have about agrivoltaics are about some very smart mounting structures with trackers and ways that you can move the solar panels. These will all come at an increased cost. So we also need to think about affordability in the region as well. So finally, this is just my last content slide, which is some ideas for a roadmap for agrivoltaic development. I'm not sure if you can see the panel speakers. Let me just move that out of the way in case you can. So starting off with a context review to explore, would agrivoltaics suit the context you're looking at? If it's the middle of a desert and there's no populations there, that's not an ideal place for an agrivoltaic system. So just an initial context review and some research into the suitability or potential suitability of agrivoltaics. Once you've identified that, it's a case of creating partnerships to conduct the project, and that will be working with a whole range of different stakeholders from different sectors, different disciplines, different backgrounds, to then develop your pilot projects. It's also worth, and I should have put this in here as well, especially in academia, this is a very important point, is the funding acquisition. So identifying where the funding sources would come from. Once you've got the funding and you've got your team set up and you're engaging with the local community, you can then construct and run your pilot system and your pilot experiments. And this is essentially where you will showcase agrivoltaic systems to the local community, and also to an extent nationally as well. It could be the case that you're setting up the first pilot agrivoltaic system in your country, so it essentially is that showcasing of the concept. And once you have your results, disseminate those results to industry, to energy and agriculture, and engaging with policy to support agrivoltaics. And then the final point is a case of we've done our job as researchers in a way. It's now, how do we support the uptake of this innovation that we've proven and optimized? And that's understanding optimal business models that will work beyond these pilot projects. So essentially supporting the rollout sustainably across the lifetime of an agrivoltaic system. And part of that could be creating a decision support tool as well to guide optimal development. So that decision support tool could contain information about how to design the solar panels, how spaced apart they should be, how raised up do they need to be, the suitability in different regions, different locations, and also the different crop types, so which crop types may grow well given the location. And actually, this is an excellent opportunity to use one of my favorite terms, and it has been for many years, and I do hope I get the definition of this right. But something that I really like is Kaizen, a Japanese term for continual improvement. So once we've got to the end of the journey, that's not it. We go back to the beginning and then we think, okay, what can we improve? How can we optimize this? Where else can we apply this? And this arrow doesn't necessarily need to go back to context review. It could be a case of going back to the partnership creation to create a new team or work with your existing team to explore a new project. So in summary, agrivoltaics offers energy, food, land use, and socioeconomic benefits, and there's huge potential for these benefits in East Africa. But there are several questions that need addressing, which need to be based on local evidence. So if you're a solar developer, an agribusiness, or say a farmer in East Africa or in West Africa, you wouldn't base your system on the agrivoltaic system in Germany, and that's where we've got our project in place. And a final point is that co-design and community engagement is key. So I'd just like to say a big thank you to the research team that I'm working with. As you can see, we have a team with spanning a lot of different specialities, so energy policy, energy modeling, climate change adaptation, agricultural sustainability. So a very diverse background team to support the many different disciplines of an agrivoltaic project. So thank you very much. I look forward to the discussion, and as I mentioned, here's some prompts for the discussion as well. And these are 3 points that Makoto mentioned as well: the sustainability of agrivoltaics, the need for knowledge sharing between agrivoltaics across Africa, and how do we go from research to pilot projects. Thank you very much. I'm not getting any sound. Sorry, Makoto, I'm just going to have to change my settings. Hi, Makoto, can you hear me? Sorry, I'm not getting any sound now.
Sorry, it's my side maybe. Can you hear me now?
Yes, I can hear you now, but I've taken my headset off, so can you hear me okay?
No. I had turned off this one, so it was my side problem. Thank you, Remy, to let me know. One of the audience let me know. Okay, you can hear me now? Can you hear me now?
Yes, I can hear you. Can you hear me?
Yes, I can.
Okay.
Okay, Remy said he can hear me now too. Sorry for the glitches that happens during the webinar. But anyway, thanks again for Richard. Thank you again, Richard, for your excellent presentation. Though we had a little glitches at the beginning, you cut off and stuff, but it also happens. And then let's move on to the next session, which is discussion. And okay, let me share this. So for the discussion, we have one more addition from Mali Folke Center, Mr. Ibrahim Togola. We want to have two of you guys cross talk about key topics that I selected for today's discussion session. And also we have a couple of questions from audience. Oh, okay. So please make sure we have a little few audiences today. I hope many of them are watching YouTube live. But I can take up some of the questions during the discussion as well. So please, if you have any questions to the to Richard or to us, please type in your question in question and answer box at the bottom of the Zoom screen. So due to the time constraint, we may not be able to answer them during the session, but we'll make sure we're gonna respond it to you by probably email. Okay. And then, this is, I want to focus today, 3 topics. First one is sustainability. During the last webinar, Richard, you yourself raised a very good question about the sustainability of microgrid or mini-grid or project in Africa. You said after donor money is pulled out, it's not sustainable. You also talked about the business model. Your ultimate goal of this pilot project is come up with a viable business model. So we want to cover this. And also the next question is expansion or extension of the project in time-wise and also in area-wise. So we are broadcasting this from Japan and as well as from Mali, which is in West Africa. So how we can extend this effort to other part of Africa. And also, of course, we have to come up with a business model that can work in Africa. And then, so for that, we may need to conduct another pilot project in somewhere, such as in Mali. So the first question, I think Ibrahim has a lot to say about it because Ibrahim is head of the Mali Folk Center, which is NGO, but he also runs a private EPC, private company, which is specialized in photovoltaics in Mali. And I think his company is one of the largest installer of microgrid or photovoltaics in western part of Africa. So
Yes.
Ibrahim, can you
Yes.
come online and then turn on your video maybe?
Yeah, but there is a turn off from your side.
Mm-hmm.
I think it says that the host deactivated. Maybe you could put it on. Maybe a question. Activate my video. Yeah, so I cannot because okay, can now.
Sorry.
Okay, good. Okay. Yeah, so thank you very much, Makoto. We also would like to thank very much Richard for the brilliant presentations. And we are really honored and pleased to co-host this webinar, Mali, for example, with ESET. And it's extremely important topics. And yes, I think like Makoto mentioned is, and I think Richard also mentioned on his presentations, the webinar is the agrivoltaic is very suitable for the microgrid and off-grid solutions. And that is something that we are extremely interested in the region here to work with Japanese experiences and And also from ESET, we are getting now more and more international experience. I think we can have a very good bridge. What is our experience on agriculture sectors in East Africa? They are very strong, and to the solar experience from West Africa, where we also have some strengths. I think what I want to say is something that for this series webinar we could discover to know each other, and because the situation on solar energy here in Mali and West Africa is very attractive. The government have a very strong policy to promote the solar with tax exemptions on all renewable energy equipments. And Mali Forest Center is working on that. And we are also working today to install many different solar off-grid as a EPC across the country. And it's the same for all the Sahel country, Mali, Burkina Faso, Niger, Senegal. But these dimensions, like Risha mentioned in his presentation, will be very suitable. Yeah, so I think if there are concrete questions, I will be willing to reply to that. I cannot hear you. Cannot hear you.
Hello, Ibrahim?
Yes.
Yeah,
Yes.
sorry. Okay. Okay, you have many microgrid projects in Mali.
Yes.
Is that a profitable business?
It's a very good question. It depends of the size of the village. It depends of the economic activity of the village. Our experience shows that any villages where you have at least you have to have about 16 hours electricity providing, and having at least 90% from solar and battery, and have at least around 500 consumer, then yes, then you can be profitable. This means the minimum capacity for that have to be around 75 kilowatt solar. Below that is very difficult, and because the operation cost, even if you have solar, is very difficult. And so that is but more you go to get your 100, 200 kilowatt hours, and more you have also more electricity consumption in daytime. That means you have a water pumping, you have cooling, you have different productive users for the daytime, then your business will be. But if it's only about lights in the evening, and that is most of your energy demand, then is a microgrid cannot be profitable business.
Okay, Richard, he mentioned that the minimum size that makes microgrid. Maybe that will be applicable to Agrivoltaics too, and 75 kilowatt. And also he mentioned a diurnal difference in the demand, electricity demand. Increasing daytime use would make the system more profitable. What do you think? Do you consider that kind of thing, difference in daytime use and nighttime use, and which is profitable and stuff, in your pilot project?
Absolutely. So in terms of the daytime, the diurnal uses, that's a big factor, because if you haven't got battery storage, then you're only going to be getting electricity during the day. But so that's where increasing features such as post-harvest processing or irrigation can increase the benefits from the system, and therefore increase alternative profits. And this is why it can be interesting, because it's not just the electricity here, it's that the electricity can power other things for the farmers during the day, which can then increase their profits from different avenues. So we've got two revenue streams, essentially. There's from the sale of the electricity, or the savings from the electricity compared to, say, diesel, or if it's connected to a grid. But the other thing is increasing incomes from the farming activities. So it's quite, in some ways, it's quite simple calculation, but it's also quite complex, because it's very different. We're having to think about the electricity production during the day and the sale of electricity, and then also the sale of the crops, and how you can use that electricity during the day to increase your income. There's a couple of points about this, though, and obviously, again, like I said, batteries can be a big difference, and that's becoming more and more integrated into off-grid agrivoltaic systems now, or it can be, and that's what we're doing with the system in Tanzania. But I also wanted to partly related to this, and also Remy's question about business models and challenges with payments, because I think that's something that also that we should discuss is actually what's the model set up. And as Remy says, there are challenges with payments and security, invoice management. And so some of the considerations is, and this isn't an answer, but this is something that somebody's mentioned to me, is pay per use. I'm not exactly sure how that model would be set up, but I remember somebody was saying about a pay per use system. But actually, I think one of the greatest things to support the sustainability of agrivoltaics is the community ownership and and making a very obvious link with the benefits for the community and the end user, and why they would want to maintain and support an agrivoltaic system. If it's just a case of an external international donor comes along, puts an agrivoltaic system in place, says use the electricity and it costs X amount per kilowatt hour, then that system may not be sustainable. It may end up kind of just not being used so much and not being profitable. But if the uses of the electricity directly benefit the livelihoods of the community, and they can see how, okay, paying with this electricity increases my income because I can power the irrigation or power these water pumps, then that can help improve the sustainability and the effectiveness by having that direct link. And that comes back to the whole thing of having that community engagement and community ownership of the system, rather than just having it as an external donor coming along, putting an agrivoltaic system in place, and then essentially leaving it at the end of the project.
Thank you, Richard. I think that the pay-per-use system you just mentioned is already in Africa. I've seen several cases that somebody else was doing it. And also community ownership, I also think is very important. And then Ibrahim is an expert on this, because community ownership is one of the three pillar elements in community power, which Ibrahim has been involved in for many, many years. Okay, Ibrahim, do you have something to say about it?
Yeah, definitely. I think energy is a very key, very important commodities, and so is a key element in the development architecture, and especially when people don't have access. And so it's very important to see when you are in a specific communities to electrify who didn't have access, and then how you can maybe structure that those communities can have, you know, the way to say and also participate. So our approach here is that we work in a way to put in place what we call the village energy committee, and that village energy committees have an option bringing all municipality and everyone together. And so they have a possibility, of course, to participate directly on the project, or they have a possibility to be a kind of key stakeholders where they participate in all the decision making. This means land, access to the land, and the construction, the EPC phase, and also the exploitation phase. So that is and now we are, when we are thinking to develop the agrivoltaics, we really think that this will be a very great model as well, to have the cooperatives in the villages, women especially, who can, because they are doing some gardening activities, and they can be the one coming to produce the vegetables and have a kind of fair price they can pay. And then also some group also can sell those vegetables in the markets, and neighboring market and so on. And also we can have a cold storage, so they can also store some of the product which cannot be sold directly. So it mean here you can bring energy to really be a kind of catalyzer of stimulating all the local economy and all the local infrastructure, the income generating in the communities. So that means we don't see that as a one coming as a private business taking all this from the communities, but really work with the communities, that even if you are a private business, you are also earning money because you are selling your electricity, but you are also part of the stimulation of the local economy and diversification of the economy for the different stakeholders, youth, women groups, and everything around. So that is really one of the beauty we see in agrivoltaic here, that we added one key component, which is a kind of farming. And the farming is the main activities of almost 80% of the communities where we are intervening. So it's quite important.
Okay, thank you, Ibrahim. You pointed out the two very important points. One is governance of the project, and then you put the main focus on the village people. You form a village energy committee, and then also you involve the municipality authorities in the committee as well. And so you act as a catalyst to a communication channel with them, and then also the community organizing. And you actually formed the cooperatives. You said mainly consist of women, which is vital force in agriculture and livelihood in the particularly in Africa. So it is very important. And your project in Richard in East Africa also think about this kind of things, right?
Yes, absolutely, and that's what a lot of the project's going to be looking into, is the impacts on the local communities and gender engagement with the systems as well. So I think that is key. And I think another point is thinking of then that, like Ibrahim mentioned, we've got these systems, some solar parks being set up in Mali. So it's a case of how do we support those to be, new designs to be agrivoltaic systems rather than. I think it sounds like there's a lot of stuff in place already that Ibrahim has. The communities, the understanding of the systems to set up an agrivoltaic system. So I think the next step would be having a pilot study which could be used to essentially showcase the benefits, because there's a lot of good conversations here about how the systems can be set up, what the potential benefits are, what's already in place in Mali. There's a lot of knowledge already there. There's a lot of understanding of how the communities could work together with these systems from an energy perspective, and these are agricultural communities. So I think what needs to happen is that the profitability and the benefits need to be demonstrated. So it's basically a case of showing that if we, in Mali, if there's a site and they pay a bit extra to raise up the systems and set it up as an agrivoltaic project, in the long term, that's more beneficial and more profitable than a conventional solar park.
Okay, thank you, Richard. Maybe we can move. I think it's a very good connection to the next questions. We are running out of time, but so extension of research pilot project to real pilot project, as well as come up with business model, and also expansion of the areas, extension of the areas from East Africa to West Africa. I think one of the audience also raised a question in line with this. Mr. Pierre, I think, Squet, sorry. What do you think are the key elements that need to be optimized to improve the affordability of agrivoltaic systems? So do you both think agrivoltaics is superior than solar parks in terms of community benefit, in terms of community benefit, maybe? Yeah. What do you think?
Yes, we do, and actually have a very good answer to this. It's back of the envelope calculation, so this isn't based on our data yet, but we looked at the cost of our solar park in Kenya, and we spoke with the developers, and they said essentially the increased height of the systems, it costs around 10% extra. So it costs 10% more to build it as a raised solar park than a normal solar park, because essentially that's what you're doing, apart from some design differences. Do what you're doing anyway, raise it up, maybe a bit more spaced apart. 10% extra in terms of cost. We then looked at the incomes from growing tomatoes from the agribusiness. We took their financial data for a plot that size, what's their annual income? And then we looked at Greg Barron-Gafford's data from Arizona. So, okay, this isn't based on data in East Africa. This is based on what Greg observed in Arizona. And we said, let's be conservative. Greg observed an 85%, I think it was, increase in tomato yields under his agrivoltaic system. So let's just be conservative and say in another semi-arid region which receives a lot of sunlight, like Arizona, in Kenya, tomato yields increase by 40%. What's that income compared to a conventional ground-mounted solar park? And the payback time was 2 years rather than 4 years, or it was just over 2 years. The return on investment was increased by, again, I can't remember the numbers exactly, but it was around 45% was the increase in the return on investment. When that also, one of the factors in with that though is that it's a grid tie system, so that was saving electricity. That's a big factor. So we were saving the electricity bills of the agribusiness by 70%. So this was very specific to this agribusiness in Kenya. It's based on a grid tie system, saving their energy bills from buying from the Kenyan Energy Authority. And also the increase in tomatoes based on Greg's data in Arizona. So like I said, very much back of the envelope calculation, but the return on investment was increased 45%. So it definitely could be, you know, profitable with the right setup and the right design. Because the main increase in cost is raising up the solar panels. But then once you've got that improved income, and potentially different crops as well. Like I said, it's not just tomatoes. We're going to try growing strawberries here as well, and that could increase an income for the farmer.
So the choice of the growing crops is another key, right? And of course, it's better to select a high value added agriculture produce, which you are not able to produce without favorable growing environment for that kind of crop, without the shade and the water provided by agrivoltaics. But with that, plus reduced energy bills, you think it's more feasible for African communities, right? What do you think, Ibrahim?
Yes, definitely. I think what I would like to add to what Richard said is, when you look at our communities, which are you know, more kind of farming communities, doing farmings and having a lot of post-harvest losses and so on, and doing also gardening activities. So when you bring energy, you know, access to energy, bring a new dimension with irrigation, proper irrigation and so on. And then also we have reducing heat and direct radiation. So, but it given opportunities for also, you know, when facilitations for the communities to have a better practice and get a better training, because when they are doing those, so it's mean directly you have a better yield on those activities they used to do. And so therefore, you know, you and when it comes to energy side, one of the main challenge we have is, you know, when you have people having a seasonal income, they have they can pay. You can see that the payment of invoices of electricity bill is better from the harvest period, I mean October, November till maybe March. And from March, because it's a dry season when people don't have more activity, so there's the payment of the bill go down. And but that is the best time also when you have a gardening activities. So by diversifying the getting water and diversifying the income generation activities, so it means you improve the income of the communities for, you know, the food and all those things they all need, but also to pay the different services, including electricity. So it's a win-win situation here between the you know, the access to water, making agrivoltaics, and also the access to energy and diversifying the economic activity. So it's extremely important in a reasonable scale, you know, for all the empowerment of the rural community, and also the resilience, what we come to sustainable development aspect.
Yeah, thank you, Ibrahim. Yeah, you mentioned that extension of growing season by electrified solar irrigation. is another key, right? And then also cold storage and post-harvest losses, decrease in post-harvest losses, which also needs electricity or energy to power it up. So in combination between energy and also, agriculture, maybe the livelihood of the African population will be better. And I want to continue this discussion more, but I think the time is almost up, so we have to wrap it up. So can you say, each one of you can say a last word towards maybe future collaboration or future plan? What do you think about the next step? Okay, starting from probably Ibrahim.
Yeah, thank you very much, Makoto, and I would like to really thank Richard to see that this is really great, to congratulate them for the great work they are doing in East Africa. And so I think we are also working quite intensively in Mali Falls under here, and also in access when it comes to the solar and rural electrifications. So only this year we are going to bring to get electricity 11 villages from the total of 21 villages. So that is a program funded by the World Bank, by the Abu Dhabi Fund for Development, and by the West African Monetary Unions. So I think we are working quite hard with East Japan to bring agrivoltaic systems, appropriate agrivoltaic systems in Sahel, in Mali. So I think we are looking forward very much to explore how to enhance this type of East-West Africa cooperations. Maybe that could be something we could find a way to learn from each other and share experiences and what we are doing. So I thank also all the ISEP team and Mali Falson team who helped on this. And yeah, and looking forward to see with Richard what can we do together in the near future.
Okay, thank you, Ibrahim. Richard?
Thanks very much, Ibrahim. I would say from these conversations that it's clear that not only is there a lot of potential for agrivoltaics in Mali, but there's also a lot of knowledge and systems already set up in place to develop agrivoltaic systems, which is great to hear. So I think the next steps would now be setting up, like you mentioned at the start, Makoto, essentially a knowledge sharing platform. We can share some of the lessons learned and our experiences from East Africa, and we can look at the systems that Ibrahim has in place in West Africa to essentially hit the ground running with the best that we can to develop the pilot studies in Mali, which will be used, as I mentioned earlier, to showcase agrivoltaics. So I think essentially it's that knowledge sharing platform to take us to the next step. And part of that would be keeping in touch, keeping the conversation going, forming a team to take this forwards, and then also identifying funding sources to develop that pilot study. But I'm very optimistic because from what I've heard from Ibrahim, it sounds like that they're already very well positioned to take on this challenge.
Thank you. Thank you, Richard.
Thank you both. So Richard said we can form knowledge sharing platform. That's one thing. Yeah, that's quite possible. And you also stressed the importance of a pilot study in Mali as well, maybe showcasing and then demonstrating the benefit of profitability of the agrivoltaic systems. It applies everywhere though, yeah, maybe not only Africa, but we have to show a lot of stakeholders that this works and that this is good. And lastly, we need to make it a bankable project and first finding funding source. Actually, it's not that easy, as you said. Okay, the money talks. Okay.
Yeah.
But particularly at the beginning. Okay, if it becomes profitable, and we after we came up with a good business model, everybody would do. but at the beginning, we have to invest money into it. So we have to find somebody. Okay, thank you. So a couple of housekeeping chores, and then we can wrap it up today's webinar. Okay. So upcoming webinars. We are scheduled to have another webinar in April and May. In April, we are still not determined, but Greg Barron-Gafford of the University of Arizona, who is quite often mentioned in the Richard presentation as a collaborator of his project as well. And he's very knowledgeable about the dry land application of agrovoltaics. So we asked him to be our next panelist, but we haven't confirmed it yet. But in May, we are going to invite Mr. Max Stromsdorf from Fraunhofer Institute for Solar Energy Systems in Freiburg, Germany. It is confirmed, and we're gonna have May webinar on May 13th. And he's going to talk about technology transfer and the lessons associated with technology transfer learned from Japanese case and Germany case, which will be very interesting. And he is focused on arid climatic zones, which is appropriate to northern part of the Africa, including West and East Africa. And lastly, for further information, please visit our website. We have all the records and the documents and the YouTube video subtitles with the English and the French, so you can still catch up our webinar series. The difference in the URL or website address is the last digit. You just type it in one of them, 903, 980, or for today's webinar, 1039, and you see other webinar series too. And all the videos recorded today and also the presentation materials in French and also English will be on the website, so you can download them freely. For the unanswered questions, we direct them to appropriate speakers for today and then let them answer to you. Okay, thank you very much for all participated in today's webinar, and then we hope to see you all again in the next webinar. Thank you, Richard. Thank you, Ibrahim, and thank you for Mari Folke Center. Okay.
Thank you. Thank you very much.
Thanks, Makoto. Thank you, Ibrahim.
Thank you, Richard. Thank you, Makoto. All the best. Yeah.
Thank you.